Okay, now I want to go over the Enable and Jog page, which is down here on the main page. The second button from your left, Enable and Jog, will toggle us to that screen. Right now you can see a bunch of buttons. If a button is bright, that means that it is currently toggled and something is being sent to the drive from that button. Right now, this button says to disable. You can disable the axis by pushing this button. So it's saying right now that the axis is enabled because you can jog the axis positive or negative because they are lit up. And if it's lit up, it means that it can be used. So it is enabled, and if you look at the servo, as I push and hold down jog positive, you will see the servo is moving. Now, if I want to disable the axis and prevent jogging while I am doing something to it, you can just click the disable, and you hear the drive click off, and prevents you from changing your jogs. You cannot touch it now. You cannot move it. Also, you can see down here there was a button that was lit up green, which said that the axis was enabled. It's lit up now. Hey, the axis is enabled. And also there's another button down here, the yellow, which is the axis is ready. Axis ready is just a flag that Crimson 3 and the software for Red Lion is seeing to say it's looking at the programs and areas and saying, hey, they are running and the axis is communicating and it's able to be enabled is basically what axis ready means. Okay, we're back on the Enable and Jog page, and we're going to go over the parameters that you can set for jogging the axis positive or negative. Again, we have the green light, so we're able to change the parameters, meaning our administration level is on full access. I'm going to the jog velocity now, and you can see that it's 1, and that stands for 1 rev a second. And my acceleration is at 10 revs a second squared. And my jog deceleration is at 1,000 revs a second squared. So basically it's going to ramp up an acceleration of 10 revs per second squared to 1 rev per second when I push jog, and it will, as long as I hold down the jog button, the servo will go 1 rev a second. And then when I let go, as soon as I let go, it's going to decel immediately at 1,000 revs per second squared to stop. We can go ahead and show you that again. Here I am jogging axis positive, and we'll pan over to the motor, and it's going about a rev per second, and now I'm going to let off, and you're going to watch how quickly it decelerates. And now I'm going to jog again in the negative direction, and you will watch it go in the counterclockwise direction. And it stops quickly. Now panning back over here to the screen, we see down here we're grabbing some units from the drive to show what the motor is doing, what is it actually experiencing physically for troubleshooting when you actually hook it up to a linear ball screw or belt or what have you. Here you have the axis torque or force. It's grabbing a flag it's actually grabbing a bit or parameter from the drive, and through a flag on the Crimson 3 is actually showing what that is in percentage of full torque of the motor, what you're actually using on the motor right now. So right now it's barely using anything, 0%. So I'm going to go in and accelerate and jog it, and you'll watch it move. You'll watch this parameter move a little bit in percentage torque as I jog it. See, it used for an instantaneous second, it used 16% to accelerate, and you saw for a second it jumped down when I decelerated. I'm going to change my jog velocity now to a higher value, 100 revs per second. I'm going to change my acceleration parameter to let's say 3 revs a second squared to give it a slower acceleration, and won't go too fast, too quickly. So it's at 3 revs per second squared, and I'm going to jog the axis positive, and we're going to watch the torque down here as I jog it, and then I'm going to apply my hand as pressure to the motor now, and you'll watch the torque increase in percentage-wise as my friction of my hand was actually making the motor work harder. Down here you can see how many revs the axis has moved from when it started. It's moved 717 revs as of right now from an arbitrary point where it started. We can go into the homing routine later that will give it an absolute starting position, and you can always use that as an absolute position to start from on the linear axis at all times. And the last parameter down here is the axis velocity, and the axis velocity shows up right now as revs per second. This can also be scaled in the scaling page, position page, for the axis velocity linearly on the actual ball screw. Okay, we have a great segue into the position units, talking about homing the axis and the parameters that can be toggled. Again, you can see here that all lights are green, meaning the administration axis is set to its highest user right. Showing here, we have a homing velocity set of max velocity when the axis is homing is at 654 revs per second. I think that's a bit high. We want to change that to 1 rev a second in this particular case. Push enter. And you can get an acceleration that you want for your homing, which means how fast you want it to get up to speed as it goes and finds its home switch. So we'll set an acceleration of 1 revs per second squared, a homing deceleration of 10 revs per second squared, and a homing final velocity of 1 as well. We want to make it home slow. And now we have our parameter set for the actual motion profile of the axis homing routine. Now again, it comes standard out of the box with revolutions, so it's talking about rotational motion. If we wanted to model it to what it's linearly translating through a ball screw or belt, then you can change through the Crimson 3 program, you can change your revs to say, let's do a linear unit, let's do inches. Okay, it's on inches. And down here, your axis units per input revolution shows your linear translation for 1 revolution would equal 1 inch. So if we had a pitch on your ball screw that was, let's say, 0.2 inches, you would enter 0.2, and for each revolution, your axis position would linearly translate 0.2 inches. As you can see up here, the axis position had changed. Now it's at 4.894 inches right now, and if I change it back to 1, you can see it's multiplied times 5, and now it's back to 24 inches. So now that we have a linear axis unit now of inches, if you go to axis units per input revolution, you can show that the linear translation of 1 revolution of your axis will equal 1 inch in this current setup. If I changed it to 2 inches, you'll see up here that the axis position will double. So right now it's at 24.469. I'm going to go in here and change the axis units per input revolution field to 2 inches. Change it to 2, push enter. And you can look up here and the axis position has doubled, gone to 48.939. So this would just help you if you have a ball screw and it has an inch lead. For every revolution that the servo turns, it turns 1 inches in linear translation. But if you wanted to double that and you had a 2 inch lead, you just simply type in 2 and your units will scale accordingly throughout the program.